Assalamualaikum viewers. So today we are going to solve question 14. A car of mass 1100 kg is traveling at a constant speed of 15 meter per second up a slope inclined at 10 degree to the horizontal. The combined forces acting on the car are directed down to the slope and are equal to W upon 5, where W is the weight of the car. What is the useful output power of the car's engine? As in question, it is asking about useful power output. Okay, so this means that is asking about the power provided by the car's engine. And of course, if we need the power provided by the car engine, so we must use the force provided by the car's engine. Okay, so this would be acting in the forward direction. And as it says in the question, that the frictional force are down the slope. So they act down the slope. So one is the forces. So force acting down the slope are the frictional forces. Okay. And second force that is acting down the slope is the horizontal component of the weight. Because when any object that is traveling upwards, up a slope, then the horizontal component of the weight would oppose its motion. Okay. Whereas if some object is traveling down the slope, then the horizontal component of the weight would drive it. Okay. It would act in the same direction of its motion. Like this. Okay. So there are two forces that are acting down the slope and only one force is acting up the slope. And as you can see that the car is traveling at the constant speed, it says in the question. So this means that the resultant force acting on the car is 0. But this means that the forces acting in the forward direction are equal to the forces acting in the backward direction. And let me clear something about how to find the horizontal component of the weight. That is this car. So this is his vertical component and this is his horizontal component. Okay. And this is the 10 degree here which is provided to us. So to find the horizontal component, as you can see that the horizontal component is to the opposite to the angle provided, and we are provided once with the hypotenuse. This is actually the right angle triangle drawn here. So we are provided with the hypotenuse, which is weight of the car, and where we have to find a horizontal component. So we would use sine theta is equals to opposite upon hypotenuse. As we already know the hypotenuse, so you would multiply the hypotenuse by sine theta and you would find the opposite. So this is how you find the opposite. This is how you find the horizontal component of the weight. Horizontal component of the weight is equals to weight into sine theta. Theta is the angle provided. So now let's move on. I have already done the working for you. So let's check on that. So power is equals to force into speed. You already know this equation. Useful power output is equals to driving force into speed. Driving force we have to find. And speed we already know, which is 15 meter per second. So driving force is equals to horizontal component of the weight plus the frictional force. Now to find the horizontal component of the weight, I have already explained it to you that you have to multiply the weight by sine theta, which is 10 degree provided to us. And weight we have to find, we are provided with the mass, which is 1100 kilogram. So you will multiply 1100 by 9.81 to calculate the weight, which is because weight is equals to mg. You must be knowing about this equation. Weight is equals to mass into g. Okay. So mass is 1100 kilogram and 9.81 is the value of g and multiply by sine 10. So you got the horizontal component of the weight. Now you have to find the frictional force. We are already provided with the expression to find the frictional force, which is this, which is W upon 5. I will clear it so you can see. Which is W upon 5. So what would you do? So you would divide the weight, which you have already calculated in the upward expression, by 5. So you would get the frictional force. Now, as we have written the expression upwards, so you would just use that expression. Driving force is equals to the frictional force, which is this one, and the horizontal component of the weight, which is this one. So you would add these both and you would get the answer. This is the driving force. You have already got the speed, which is in 15 meter per second. So when you would multiply the driving force by the speed, you would get your answer as 60,000 almost. When you round it off, So your final answer would be 60K, 60 kilowatt. So option C is the correct answer for this question. Thank you so much for watching. Still, if you have any doubt, you may ask in the comment section.